picture. Now, this is a process called gasification. The gas coming off there should be flammable. What's happening is that when heated in this way, the wood breaks down to produce carbon monoxide and hydrogen. Now, if I feed that gas into my cylinder, okay, so going in, drop the piston, get ready with the spark, 3, 2, 1. Well, that works, totally works. So, in theory, wood gas is like a piston, but can we scale it up enough to drive a car? Gasification is not a new idea. During World War II, due to petrol shortages, thousands of cars ran on the gas from smouldering wood. But nowadays the environment is the worry, and chopping down trees might not be the answer. So I've been on the hunt for a substance as like wood, but it's actually a complete waste product. And after numerous burn tests, I think I found our perfect substitute. Yep, coffee. I'm going to drive my car on used coffee grounds, stuff that's usually just dumped in the bin. And how is that possible? Well, it turns out that used coffee grounds actually give as good, if not better gas than wood. But to burn efficiently in a gasifier, like a giant version of my kettle, they need to be very dry and ideally made into these pellets. Now, a massive handful of these pellets should get me about 2 miles. So that's around 66 EPM espressos per mile. Or the dregs of 41 espressos per kilometre. And if the fuel choice wasn't challenging enough, this is what I'm making the gasifier with. A pile of scrap metal. Time to cut, chop, weld and grind, persuading our second-hand steel into its new role as a mobile gas production plant. We need a system both small enough to mount on the car and safe enough for other road users, because we're playing with explosive and poisonous gases. A lot of blood, sweat and tears have gone into this copper-powered car. Now, we've still got the same 1980s boy racer special, but we've added a bit. It's now a system that converts waste into useful fuel. This is the key to the operation. This old propane bottle. Normally, when you burn wood-like substances, you get a mixture of carbon dioxide and steam given off. But this reduces those gases to the highly flammable carbon monoxide and hydrogen. When it leaves, it's in a fairly dirty, wet state, and we need to clean it up before we feed it into the engine. First, we turn it into here. Then the gases flow around so fast that all subparticles get whizzed off to the edge and drop out. A bit like a kind of high-temperature cyclone vacuum cleaner. Then it goes there, into that radiator, where the gases cool down and we condense out some of the water vapour. Then out of the radiator into the fine filter, where we remove even more of the smoke and tars. Then, it's down this pipe on the way to the engine. I've not got the engine running, so I've got a fan sucking the smoke through. I think we're in business. Look at that! It's like an Olympic torch! It's this mix of carbon monoxide and hydrogen that's going to power me 210 miles from London to Manchester.
Sometimes the Earth just isn't big enough. Sometimes you need an even bigger view. Strap in for space season on Discovery Science and explore infinite worlds with the biggest brains on the planet.
Hello.
Revisit the golden age of space travel.
Bring them pussy.
And see into the future. It's all on space season. Starts Monday at 9:50 on Discovery Science.
We humans are a curious species. We wonder. We seek answers. So can we answer the greatest question of all? Is there a meaning to life? For what I call the
Stephen Hawking's grand design. Heart of Space Season starts Wednesday the 3rd of October, exclusive on Discovery Science.
Hey, now listen, there's a lot of interest at the moment about the possibilities of there being life elsewhere in the universe, and research into that sort of stuff is helping us understand how life might have started here on Earth.
Patayin niyo muna. Gumagalaw pa yan kaya hindi yan. Baka nakita ko yung lalong gumagalaw.
So my quest to get to the bottom of all this starts with an experiment that took place in Chicago in 1952. And this is a reconstruction of it. It's the classic Stanley Miller-Harold-Urey experiment. And essentially what it is a closed system designed to replicate the conditions on Earth several billion years ago. So up here we've got our atmosphere. It's filled with basic gases like hydrogen, methane and ammonia. Very different, of course, to the atmosphere we've got now. Down here, bubbling away, you've got a primitive ocean creating water vapour. The whole lot mixes here. And what they did was they actually put a spark through the whole lot. Two electrodes to simulate lightning, and then they went away for a week to see what happened. So they came back after a week and had a little look inside, and what they found was this rather unpleasant, brown, sticky, smelly stuff. But when they analysed it, they found it was full of chemicals called amino acids. Now, not life itself, but certainly part of the building blocks that can make life possible. This gunk, made from simple gases and a spark of electricity, was full of complex chemicals which could go on to make life. Indeed, for all its flaws, the Miller-Urey experiment suggested we might be getting close to learning how it all began. And that led others to speculate about another controversial idea. If the basic chemicals we need for life could be created here on Earth, then could they have been created elsewhere in the universe? That wasn't quite as mad as it may seem. We're fairly sure there are planets not too different from Earth elsewhere in the universe. Could the building blocks of life have been carried from one of them? Or could it even have been formed in the depths of space itself? For instance, in 1969, a meteorite fell to the Earth in southern Australia called the Murchison meteorite, and that weighed over 100 kilograms. That's more than I weigh. Now, if you're hoping to find the building blocks of life in space, looking at meteorites like Murchison might be a good place to start. So, a handful of scientists here at Imperial College in London have recently been analysing meteorites like Murchison with startling results. This is an actual fragment of meteorite that fell from space to Earth. It's over 4.5 billion years old, untouched by human hands. This is Zita Martin from Imperial College. Now you're an astrobiologist, so it's your job to actually analyse these and find out what kind of molecules are present. Can we sort of do that?
Yeah, of course.
This is a mass spectrometer, a fantastic bit of kit that can analyse the chemicals within our meteorites with incredible accuracy. Okay, so here are our results. So if I just scroll down, what are we actually seeing here?
We're seeing a molecule called uracil, which is a molecule present in our genetic material.
Yes.
So this is really exciting results.
It's a hugely significant find. Uracil is one of life's basic building blocks, and this one seems to come from outer space, making it controversial stuff. So controversial that many scientists argue that the results might be inaccurate because the meteorite could have been contaminated by life on Earth. But for the first time, Zita's results proved categorically that those chemicals were of extraterrestrial origin. Normally, uracil is made from the element carbon-12,
But the Uracil and the Murchison meteorite contain a very high ratio of carbon-13, incredibly rare on Earth, but common in space.
So when we look to our results, we know that we have a much bigger ratio of carbon-13 over 12, and therefore this molecule, the uracil, can only be formed in outer space, and it's not contamination.
So there's absolutely no way that can be synthesized on Earth.
No.
This is such an important
Para
thing.
sila kayong
How did it make you feel?
naging sila ng dagat.
Well, it was very, very exciting news and discovery, and we were the first ones really proving that components of our genetic material were present already in our early solar system. So that's really big news and exciting and everything.
Well, that's pretty amazing. So I guess the kind of $1 million question, life here on Earth, did we sort of come from space?
Well, you can't say that. We're not saying that meteorites brought life itself. We're just saying he brought the building blocks of life.
So, are we aliens? Well, these are the facts. Thanks to Zita and her team, incredibly, we now know the most basic building blocks of life exist in space. And over the years have definitely come to Earth from space. And for me, that's almost as exciting.
So if the building blocks for all life on Earth came from outer space, did those same building blocks lead to life on other planets? I need to know more about this.
I intend to find out.
Good.
I'm making my mission to find out.
I need to build one of those life-making rigs. They are simply awesome. They do. Anyway, now it's time to go back to the future on my junk-fueled car. London to Manchester, 200 miles in a 1980s vehicle converted to run on coffee. Ambitious is an understatement. London is a good night. It's been pretty quiet, and I quite like it that way, because this thing's not exactly straightforward to drive, because what you do is when you drive it, you're also running a gas plant at the same time. I set up early because I wanted to make sure I'd be at the Science Festival in Manchester by 3 p.m. Dallas and Liz were already there, having sensibly chosen the train. It was a relief to get onto the motorway, where I wouldn't have to constantly fight to match the varying power demands of the engine to the production rate of my gas plant. This is 65 miles an hour now. This is as good as it gets. Well, hopefully it might even get better. But 30 miles up the road, we had to pull over. Our prototype coffee-powered car had got the jitters. It was just out of fuel. And back on the road, it looked like with enough coffee, anything was possible. But there was one thing I had no control over.
There's still more delays on the M1 northbound up towards junction 15, where that closure is in place for recovery of that lorry and the car.
After finally escaping the traffic, the team and I had to service the coffee conversion kit in the boot. We have to do this every 60 miles. Each service would eat up precious time, but if we didn't do it, we'd never get to Manchester. At every stop we have to drain the water, replace the filter, coffee, and deal with the red-hot coals.
Pinapakina din sa loob eh. Ito lang.
To actually understand work properly, you have to clean the ash out periodically. Otherwise, it sort of shuts it and I can't get the gas that you
Lalim, sa gitna yan.
I just hoped our cappuccino would become an espresso, because I still had another 130 miles to go.
Okay, so we should be here in 2 hours if everything's going well, right?
You should be here now. We've made it for London so far. Let's go to Manchester. Thank you, we're going to leave. Oh no! It was nice to make new friends, but it was proving almost impossible to match the gas production rate to the car's speed.
Paglagyan mo pa ng isa dyan, ayaw, hindi na pupunan na.
Hindi, basta. Hintay pa. Lalim na oh. Dali lang yun napasok eh. Dali-dali lang yung pinasok. Kung ano yan, hirap yan. Dapat matagal yan, hindi ganyan.
Absolute dream. It's just in traffic like this.
Ayun na oh. Doon, naiiwan sa pwesto eh.
Wala yun siya mga pambayo.
Daba na ulo. yan.
Now with the fire extinguisher,
Mahaba na pala.
was in our sight.
18 inches dun yan eh.
Ha?
18.
Cheers.
This is Manchester.
Nung nakuha. Ngayon,
Ewan ko, hindi ko nasusukat eh.
laki na yan.
Baka may metro sukatan. Kaya gawa kang panipit eh. Ganun. Sinisipit ko na kaagad yun eh.
Pero yung pag ginagawa, inuulat na no?
Oo. Pag inuhuli ko, yung hanger, lalagyan ko ng bilog sa dulo. Tapos yung catchings, may nakabilog. Pag hinila ko, sasara. Tapos makuhuli mo, o sige, alam ka. Tapos sila ko hawakan.
Layo siguro.
Apo.
Laro pa pa niya.
Ayun pa, oh. Tama, oh. Ayun, oh.
Ayos na.
Tama. Baka pa eh.
12 na yan, di.
Ikot siya.
Ito nga basta 12 yan ah.
Oo, may 12.
Bright spark got sick of walking everywhere. And after that, there were things that could get you over water. Things with two wheels. Four wheels.
Ako,
Dalawang ruler na.
oh.
Things you could slide down the slopes on. Look how happy he is. Things that could take you places you thought you were stuck on the